Okay, Token Drop episode 21. So, what I'd like to talk about today is I was on TikTok the other day and I saw this interview with Vinod Khosla. He's the famous Silicon Valley VC. He's also the new owner of the NFL Seattle Seahawks. And he was being interviewed talking about domain AI systems. And I also read a post of his on X on that same topic. So he said that if you consult ChatGPT for medical info, the general triage error rate is 20 to 30%. He said, meaning that you get the wrong answer 20 to 30% of the time. He said the solution is to layer things on top of the LLM. He said his son has a company that does just this, and they use GPT-5 and layered things on top, and their triage error rate goes to zero. He goes on and says this is not just a problem limited to healthcare, but other industries like national defense, financial trading. And I just wanted to maybe start off by saying, why is this a problem? Why are the LLMs, first, do you agree? And then why are the LLMs behaving in this manner? What do you
Yeah,
think, Steph?
Sam, you want to go first?
Go ahead,
Sorry,
Sajjad.
yeah, I can go. I think
Oh,
uh,
were you
the question
expecting me
is,
to say something or or so yeah, go ahead, yeah, if you want it. So okay, let
no
me start.
problem.
Anyways,
Go ahead.
so
Yeah.
I think Vinod Khosla keeps getting asked why anyone should build on top of a frontier model when frontier models already exist. That's the point, right? His answer is a number. I listened to his talk. Raw ChatGPT gets medical triage wrong 20 to 30% of the time, he says, right? And he says layer a domain system on top of the same model, and the error rate goes to zero. Half of that, according to me, is investor shorthand. The other half is the most important architectural claim in enterprise AI right now, right? It's worth pulling apart between the difference between shorthand and the truth, because that is the truth is exactly the thing that you need to build, right? I mean, so I will start with that, and then I'll start a little bit more when I say let's talk about a patient, right? Not a benchmark. Take one use case, right? A patient types their symptoms into a health chatbot. Excessive thirst, confusion, rapid breathing I have, fruity breath, kind of that stuff, right? Any emergency physician recognizes, oh, that's diabetic ketoacidosis, right? The correct triage is the emergency department now, right? So in February 2026, a stress test published in Nature Medicine ran exactly this kind of case through ChatGPT Health, right? OpenAI's consumer health product, that is that's the one actually, ChatGPT Health, right? Used by tens of millions of people. The system under triage 52% of gold standard emergencies. Would you believe that? It sent the DKA patient and a patient with impending respiratory failure to see a doctor within 24 to 48 hours. Now, I think that is so costless 20 to 30% is, if anything, generous. In the cases where being wrong kills people, the raw model was wrong more than half the time, actually. So therefore, I will leave it at that. The study found something worse when for example when the Vignit mentioned that a friend had said to the symptoms were probably nothing. The model became almost 12 times more likely to downgrade the
Well,
urgency.
why is that, Sam? So maybe going back to my question is why is it uh, behaving like that? Why do LLMs do this?
We have talked on our podcast several times about this, right? I mean, basically, they are being trained on internet data, right? And when you come to things like this, when people are asking domain-specific questions, like with respect to healthcare, or even specific things with respect to diseases, the LLMs, might not have the context, and they have not been trained on specific medical data, actually, right? So whenever they hallucinate, they cook up an explanation for it, actually, and that explanation is fluent English. It's not anything backed by provenance. So therefore, what happens is it can say whatever it wants, And whoever follows that, it's like this. I have a case when I heard once a guy was using ChatGPT and he was driving his car. It took him all the way onto the Bay Bridge, and somewhere there, it asked him to take a left turn. Had he done that, he would have
Yes.
died. Okay.
Yes.
So it's the similar situation here where somebody goes to ChatGPT, puts in a bunch of questions. And I really see this. I mean, all my members in my family do that actually. They go back and say, I have a headache, I have related this stuff, and they try to diagnose. They become doctors by themselves by asking the LLM, what should be the cause? How can I mitigate this cause, right? I mean, it's cool to do that, but the problem is, end of the day, how much of it can you believe? There is so much amount of stuff that is going on where the LLMs hallucinate and their answers may not be the right answer. I will let Sajjad talk a little bit more on that, like, but he can give the basics behind that, right?
Yeah,
And
the why.
whys behind it. But I just give you I've set the context of that whole thing right now.
Yeah, I think, Sam, you're right. Genetically, LLMs are predisposed to, in fact, the reward function rewards them for producing an answer, whether the answer is right or wrong, right? And they're genetically predisposed to making predictions, and those predictions could be wrong. And and I think it's now an acknowledged fact that every once in a while an LLM can give you incorrect answers. But without, going back to the topic, right? Really, when Vinod Khosla said that his son has built some technology as a layer on top of an LLM that mitigates these risks and reduces those errors down to zero. Um, and we don't quite know what technology they've built. But if you look at the industry, we started with loop engineering only a few months ago. Oh, you just retry the same action in a loop and hope like hell that somewhere one of those iterations through the loop you'll get a right answer. No, that's really not a good way to go around. I mean, you're now spending a lot of times in the loop, burning a lot of tokens and hoping like hell that you'll get the right answer. So that's one approach. And then the industry has caught on to something called harness engineering, where harness engineering is all about loop plus context plus some verification, and then hoping somehow that magically you will get exact and accurate answers all the time, right? And we've been advocating for a long time that you really need to ground those answers in knowledge. And effectively, we've always been making the case that use the LLM for its language skills and offload all the knowledge processing tasks onto an outboard engine. That outboard engine processes knowledge. And after the knowledge is processed, you give the knowledge artifacts back to the LLM to generate the final answer. Even then, the LLMs are predisposed to generating incorrect answers. So post the synthesis also, you still need to do some verification and rectification. What we've also found is if you could replace the LLM with a deterministic NLP generating engine that generates NLP using traditional NLP engines for generating those answers, given the knowledge artifacts, you're more likely to be generating, acceptable answers all the time. That's the way that's one technique you can use to reduce those errors to zero. Now, whether Vinod's son's company brought those errors down to zero or they brought them down asymptotically closer to zero, we don't know the answer. Yeah.
I was reading through these comments also on the X post, and it was interesting because I wanted to try and see what other people are thinking about this. And a couple of posts stuck out at me. And one person said you can use RLHF, reinforcement learning from human feedback, which is basically to fine tune the model. And another one was saying, hey, you can do distillation.
Yeah.
And both of them seem to be saying, if I understood it correctly, hey, just do more job and a better job in training the model rather than,
And it's,
addressing.
yeah,
Is that really the cause of this? Is the models not been trained properly, or is it something deeper?
I think, the Frontier Labs has spent billions of dollars in doing exactly that, right? Effectively using RLHF to aligning the model's answers to what humans expect as correct and accurate answers. But the cognitive surface is so large, the domains are so many. Have they done that across each and every domain and across every potential variant of the question that ends up being asked? The answer would be no, right? Statistically, it's impossible. And even if you did so, still, there's no guarantee the LLMs will give you correct answers. So while those are good techniques in mitigating some of those risks, but they don't reduce those risks down to zero, right? And these are techniques. RLHF has been around. I mean, OpenAI has been using RLHF from ever since ChatGPT was launched, right, in 2022. That was. So, yeah, I think those are all good techniques, but they're not the silver bullet in reducing the answer down to zero, in reducing those errors down to zero.
What do you think,
Well,
Sam?
the real thing is, Sujat alluded to it, but let me put it this way: every serious builder, can rent the same frontier models, right? The model is a commodity; it has an API, and if your product is a model plus a prompt, that product is a margin waiting to be compressed, right? That is the whole idea. But the domain layer, what you're talking about, is different. Why is it different, right? I mean, it is different because if you're building a domain where being wrong has a cost, like what? Medicine, payments, compliance, infrastructure. The question isn't which model to use. The models converge. The question is what sits between the model's proposals and your customer's outcome, actually. The uncomfortable part is that the layer is slow to build. Encoding a domain means finding the people who hold the rules in their heads and getting the rules out case by case, exception by exception. There's no pre-training shortcut. That's precisely why it defends. The work everyone skips is the work nobody can copy, actually, right? So Khosla zero isn't real, but the direction is. The value of the model is capped by everyone having it, right? The value of knowing it, knowing when the model can't be trusted is capped by nothing, actually, right? I mean, so therefore, what happens fundamentally is the rules say decay is an emergency didn't come from a training run. It came from clinical knowledge encoded by people who understood the field, validated against the cases, and refined every time the system caught something or missed something, right? That artifact, the rules, the vocabulary, the validation logic, the escalation paths belongs to whoever built it, actually. So it doesn't ship with the next model release and doesn't get commoditized when the next model release arrives. It gets more valuable because a better proposer makes the same verifier catch fewer errors and pass more work through. So that is what Khosla means by necessary but not sufficient, because whether or not you phrase it this way, the frontier model is the engine, the domain layer, he says, is the car, the brakes, the crumple zones, the dashboard like that comes on when something goes wrong. Nobody gets into
Yeah.
an engine, actually, right?
By the way, I think he chose his words very carefully. I think he said it goes towards zero. I don't think he said it is zero.
Yeah,
So it's asymptotically going towards zero. And I
yeah,
think that's correct, is what you're saying. I think so too. But it's not zero yet, is what
yeah.
you're saying, right? And
So
can it be zero? Can it ever
I
be zero?
mean,
Because there's still,
that is the whole fallacy, right? No system can reach that target, actually. I mean, the real reason being that it's mathematically not possible. I mean, that is the error rate going to zero is something like saying that. You know, I mean, I don't think that is marketing fluff actually at that level. But other than that, whatever he says has been in line. We have been talking about it. We said all this in our earlier podcast. The LLM cannot be the right place to store knowledge. We really talked about the fact that it needs to be external. And then we talked about multiple representations of that knowledge outside the LLM space, right? How do you represent it? Or graph racks the best thing? Or is knowledge graphs the correct thing? Or even for that matter, we talked with Kurt on this whole thing about the dimension of time, about the dimension of context. We have talked about all these things. So there are a lot more things the LLM doesn't capture properly. And the most fundamental thing I think about when I think about LLM is they don't capture experiences. You are in the situation and you experience it. And that experience gives you some kind of wisdom because there is this case of failure and success. The LLMs are not there. They're just reading text. So they don't have the coupled experience, world experience, and therefore you have to bolt on top of it something else to allow it to have that experience. And you know, there are different ways of people are trying it, but still unproven, right? So I really think that we are saying something went to like 0% is not believable until I see it, right? I mean, but our approach towards a DAX moving towards grounded truth is the right approach. We don't overclaim what's possible and we don't understate either. We give facts as they come through, right? And that's where the real story is actually.
And I think it's also a function of the use cases, right? So we sometimes tend to assume those autonomous, unattended use cases where the LLM or the system has to be 100% accurate all the time, every time. But not every medical use case is like that. For instance, medical transcription. You're having a patient physician conversation, and that's being transcribed by one of these models. And then at the end of the transcription, it is incumbent on the physician to review those notes and to approve them. So you have a human who's in the loop, reviewing the output, verifying and validating and ascertaining that that answer was a good answer, right? So, and I think there are plenty of those kinds of human in the loop kind of use cases where the systems that Vinod was referring to might still be helpful. But if you take the extremity of these unattended autonomous systems that make decisions and are expected to be 100% accurate, those are the systems that we are planning for and trying to say they need to be accurate, precise, and you need to go to extremities of engineering to making sure that they deliver on the promise of zero error.
Yeah, absolutely. I mean, because I think one of the main things that the fact of the matter is even before verification, right? One of the things I've been thinking about, and I did talk about it to Kurt also earlier when I was discussing with him, was you have an intent. The user has an intent, and that intent is something we are taking in and we are giving something out. How do you know that that intent which the user intended is exactly captured in the semantics? I mean, is the real user intent really captured? How do we know that? Because if the
Yes.
intent is not good, the outcome is not good either. Garbage in, garbage
Yeah.
out. So fundamentally, that is the problem. And I think we need to talk about it in a separate podcast later, where we will say how intent really needs to be translated into exact semantics. Now, the question is natural language a good way of really expressing intent? I don't think so. Because the reason is natural language is ambiguous, actually. There are many things in natural language which make it not the right language. That's why you see most of the domains have their own domain-specific languages. They're called DSLs, actually. If domains have DSLs and natural language cannot express intent properly, how do we really move from natural language to DSLs? That is a bigger problem that the industry is grappling with for quite a number of years, actually. Right. So therefore, that is where the whole thing. So there are two different gates here. A gate where intent needs to be properly translated, and then the second part, which DAX is doing, verification again with provenance. We have gained mastery over the second part, but on the first part, the main thing is we need to be able to say yes with certain amount of confidence. We translated what the user wanted into something like the whole intent was translated. To what extent? 90%, 95%. How do we really do that? How can we prove that? Those are the most interesting questions now in the field, actually, where you can prove intent, right?
So Sam, this thing about Vinod, he talked about a couple of different markets. He talked about healthcare, then national defense and financial trading, and I'm sure we can think of about a bunch of others. But what was interesting to me is that in national defense, most of the data, it would seem to me, is dark data. It's not publicly available. I
Correct.
mean, I don't think you'd want to put all the defense information out on the internet for training for an LLM.
Yeah.
So unless you fine tune that LLM or retrain it with all this as a private LLM,
Correct.
it's not going to know. And I'm sure for same thing for financial trading, the specific algorithms that they use and methodologies, they don't want to make them public.
See, I
Right.
tell you one
Healthcare is
thing.
probably different because there is a whole body of public information. You want to make it public because you want it to
Yeah.
share it so that
Yeah.
people can improve their health worldwide. But in some domains, I don't think you want to make your information public.
But the
So it seems
problem
like
is,
Yeah,
in,
I mean, there is a big thing here. Like, think about the proprietary Unix systems in early days. They used to have bugs in them, right? Why did Linux become so powerful? Because everybody could look at open source. They can investigate what the code is. They know exactly. So the power comes when multiple people can look at the same thing
yeah,
and
but you can't
critically
do that for
analyze it.
defense. I mean, you're not going to do that for defense. So,
We're not going to do the difference. That is the real problem there, because
yeah.
your space is so confined, where there are only certain privileged people who and privileged data there through which we are training, actually, and we do not know for sure if it covers the entire gamut of the domain that we are dealing with, actually, unfortunately, right? So
Yeah.
that is the same thing. Like, for example, we have many restrictions with the patient data. So we cannot do proper diagnosis because that data is not available. They are protected. And you need user consent for that, right? So if you want to do development, or if you want to really do cost analysis, you don't have enough data at all, actually. And that's a bigger bottleneck. And this has been the case in every domain, not just in healthcare alone. It has been in telecom, where systems, and now we also have all these data sovereignty issues and things like that. So GDPR. So people are really afraid to share data, right? I mean, and also people are afraid to. They do not know where this data would be used, actually, right? It can be even used against them, like insurance companies, things like that. So therefore, I really think it becomes very. You brought a very important point. Supervised fine tuning may get us a little bit more than what the foundation models provide, but they are not the solution. We need a complete domain layer which can really sit in the middle and be able to translate properly the user's intent, and then be able to provide provenance and guidance over where that data, where that answer came from, actually, which we need
Yeah.
both.
So, Sam, let me ask Sajjad his opinion on this.
yeah. I think I don't know much about defense, but I do know a little bit about these advanced financial systems. So, and we were engineering some of those platforms long ago, and we have some experience doing that. And I think those systems, I mean, if you recall, the most famous example in this space is that of Bloomberg. They tried to build an LLM on their own. They spent $42 million, And after a while, they have given up that effort. They've gone back to using a frontier model. So they're using frontier models largely for interpreting all kinds of signals, right? At the end of the day, a trader is interested in all kinds of business and news signals. And to analyze those signals, an LLM is probably a good tool. And then to replay the trading strategies, they need symbolic AI, right? They use Monte Carlo methods, they use simulation and modeling, they do back testing, they do options pricing, they do a lot of these things, a good number of which are symbolic methods. So I think it's a great example of neuro-symbolic systems being built by this, the crowd that we used to call, what are they called? Lightning, flash, flash trading, right? It's called flash trading. So it used to be all about speed at one point in time, but now it's about speed plus intelligence. Speed matters, but intelligence matters more so. And intelligence is a combination of LLMs and then symbolic methods. And even the LLMs here tend to be slow. How do you generate these candidate, proposals and then have your verifiers or Monte Carlo methods verify and run through all kinds of simulations to see if those are, if those candidate proposals can stand the, rigors of their verification. So, yeah, and I think they struggle. And I think one thing to be said about LLMs is they're not necessarily fast. These are not exactly low latency systems. So I'm sure their trading strategies, their uh, you know, their proprietary trading methods are done offline in a day before, but then they run a lot of simulations on that before they pull the trigger on whether to buy, sell, or short a particular trade. So I think those are examples of neuro-symbolic architectures, I would say. And these are finely evolved, and they've evolved over quite a long period of time. So yes, I can't speak about defense, but I can certainly speak about a little bit about what happens in the financial industry.
Okay, I think that we've reached our limit. Anything else you guys want to say?
No, I mean, I think we have talked about it pretty much, right? So therefore, the moat argument is rules are the durable asset, right? A better model makes the same verifier more valuable, not obsolete. So I think domain layers don't reduce model error; they convert silent errors to caught errors. That is what, and the shift risk from model might be wrong about anything to rules might be incomplete, and that should be auditable, which is what our neuro-symbolic pitch is actually, right? So we are exactly saying the same thing as what Khosla is saying, actually.
Okay, well, that's it, I think. Thank you guys. We'll talk to you both later.
Thanks.
Thank you.
Thank you.
Thank you.